Hello everyone, my name is Tadiwa Mtizwa and I'm here to share with you a small talk about the water cycle and the properties of water. So before we begin with the water cycle, let us have a closer look at the main actor in this whole story, which is the water molecule. So what is the water molecule made up of? The water molecule is made up of an oxygen bonded to two hydrogens. So this gives it a couple of very interesting properties. Because the oxygen atom attracts a lot of the electrons, it has a slightly negative charge, whilst the hydrogens bonded to it, since they have lost some of the electrons to the oxygen, they are slightly positive. So which makes water have polarity. What do I mean by polarity? It means that it has a negative end and a positive end. So for example, just like magnets, because they have a positive and a negative, they tend to stick together. And this is the same thing that we find with the water molecule. So this sticking together of water molecules, this is a bond which is called, it's a special type of bond called the hydrogen bond. So the hydrogen bond is a weak bond, but it is actually important in giving water some of its emergent properties. So one of the major properties, as I've already mentioned, about water being polar is that it is sticky, which means it is cohesive as well as adhesive. So what do I mean by these two terms? When we talk about cohesion, we're talking about the ability of water molecules to stick together. And you can see this with water molecules when you have steam in the morning, and like you have steam on a cold window if you're in a car, or maybe in your house and it's been cold outside. You see those little droplets that start forming on the surface of a glass. Like for example, in this case, I had hot water in here, but because it was evaporating, some of the water molecules actually start sticking to the glass. So that is adhesion, the ability of these water molecules to stick to another surface. But also the ability to form these little water droplets is also cohesion, the ability of water molecules to stick together. And these are very important properties that allow water to do some very special things within the water cycle, as well as being part of our life. So I'll get into these properties further. So another ability of water is, because of its polarity, it is a very good solvent. It is able to, if you've ever had a situation where you put salt within water and just mix it around, you find that the salt dissolves because water acts as a solvent. Because it is able to dissolve hydrophilic molecules, like for example ionic compounds, like for example sodium chloride, which is salt. Because sodium chloride also has a positive and a negative chloride ion and a positive sodium ion, it is able to be dissolved. So that's one of the major properties of water, its ability to be a solvent. Another property of water is high specific heat capacity, which refers to its ability to the high amount of energy required to change water from one state to another. If you've ever had to boil water and put water in a kettle and you had to wait for 5 minutes, you'd be like, you've realized just how long it takes for you to boil water. And how does this help out within the water cycle? It means that water is a relatively stable substance. Like, of course it evaporates, but it doesn't evaporate as quickly as other substances. And that's why you can have water staying in lakes and rivers and the sea without it completely just vaporizing out quickly. And also it explains why even if you have ice, it actually, as long as you don't put the ice in the water, it actually takes a long time for the ice to actually melt. It's because of this high specific heat capacity of water. So I'll then explain further as to how this helps out within the other processes involved in the water cycle. So yes, water, here on planet Earth, we find water in three forms. We find it in the gaseous state. I don't know if you can see the steam of this boiling water coming out. So this is the gaseous state, or steam as we commonly call it. And then the second form is of course the liquid. I guess we also have liquid in here, liquid gas. So we have the liquid state as well. Then the third form is the solid state, which is ice. So because of the hydrogen bonding that happens within water molecules, you find that shifting between any of these three states requires a lot of energy. and this relates to the high specific heat capacity of water. But another peculiar property that hydrogen bonds give water is this ability to form a solid state which is actually less dense than the liquid state. Well, if you look at most substances, the solid state is usually more dense because the molecules are vibrating less, so you find that they are closely packed. But in water, because of the hydrogen bonding, they actually form a lattice, and this lattice has small gaps in between each molecule, which results in solid solid state, which is ice, being less dense than water. And you can see this in a very simple demonstration. When we pour liquid water into a bowl like this, you find that actually the ice floats on top of the liquid, showing that solid state of water, that is ice, is less dense than the liquid state. And this is very important in systems like lakes in colder regions of the world, whereby during winter the lakes freeze over. So the lake does not completely freeze over. What actually freezes over is the surface of that lake, and this allows that liquid water underneath that ice, and that ice actually forms an extra insulation layer, preventing further freezing of water underneath. And what is the benefit of that? It means that even during winter, when the top of the lake is frozen, we still have organisms like fish, plants, and everything can still live under the ice within the liquid state, underneath that ice cap. So this is a very important property of water. So yeah, this is the water cycle, which is basically a process by which water is circulated through the atmosphere and the earth. So we all have water in our homes, in the workplaces. Probably you have a bottle of water sitting at your desk there, and you're wondering, where does this water come from? So the water cycle is, like I said, it's a global process that involves the circulation of water through the earth and the atmosphere. So how does, as I've already spoken about the ability of water to change into three different states: the gaseous form, which is steam, the liquid form, which is the water that you're drinking in your cup, in your bottle that comes out of the tap, or the solid state, which is ice. So in order to change from one state to another, you either lose energy or you gain energy. And on Earth here, that water process, the energy required for water to change between those different states is driven by the sun. So all the energy that powers the water cycle starts from the sun. So energy from the solar energy coming from the sun heats the water surfaces, and as you may know, the earth is about 70% covered by water, which is water in the seas, as well as water in lakes, rivers. So you find that when that solar energy comes, it heats that water on the surface, and then it starts the process of evaporation. So basically, it is changing the liquid state of water into the gaseous state of water through this process of evaporation. So this evaporated water then rises up, and as it goes further up into the atmosphere, it becomes cooler. Because the higher you go, there is less heat there, and the molecules are losing energy. So when they are losing energy, they actually start sticking together. Remember, one of the emergent property that we spoke about, which is the cohesion, the cohesive ability of water. That is the ability of water molecules to stick together. So as they lose energy, they start vibrating at a slower speed, and they eventually start sticking together, forming droplets. And these droplets are what actually form clouds. So clouds are actually just big blobs of condensed water that has formed into very small droplets, and in some cases they're actually small ice particles. So and this process is called condensation. So as they get cooler and cooler, they condense, and these molecules, these droplets get bigger and bigger and bigger. So as they are condensing through the activity of wind, they're actually blown from one place to another. So we can have water evaporating from the sea or from a lake, and then it's transported by the wind. And this, as it is transported, it then moves to another area, right? And as this is happening, these droplets are getting larger and larger, right? And they eventually get to a point where they are now so big, they are heavy, and they start falling. And when they start falling, that is what we call precipitation. And what is precipitation? Precipitation is basically this condensed water that is now falling from the cloud, and it can be in the form of rain, sleet, snow. So all the rain that you see outside is just precipitation. It is all that water that started off evaporating from one area, and then it condensed, it got larger, and became heavy and started falling on the earth. And that's how we get rain. So as the rain falls, it then falls onto the ground, and it flows into rivers. Some of it, if it's in the colder areas, it can actually form ice. And like in Africa, you can have the mountains that are kept by ice, for example, Kilimanjaro. So some of it may form snow and actually be trapped in the ice in these really cold places. But for the majority of us living down here in southern Africa, the rain flows into the ground and it actually starts to run off. So a lot of the rain that falls will run off into streams and rivers and begin to flow down the river as it leads to the sea. Some of it will then go into the ground through a process called infiltration. So infiltration is basically a process whereby the surface water is entering into the soil. So this is responsible for rehydrating the soil and making sure that there's moisture within the soil. There's another process that happens after infiltration, which is called percolation. So percolation is like, now we have that soil which is wet. That further filtering of water into the groundwater to form these aquifers down where we actually, when you have a bowl at your home or a bowl at school, we're actually drilling water which is groundwater. And how do those groundwater aquifers get filled? They're filled by a process called percolation, which is basically the filtration of water down through the soil into the groundwater system. So the precipitation, as we just highlight, some of it runs off in rivers and streams, some of it infiltrates into the soil, some of it even goes further down into the groundwater, recharging aquifers underwater. As well as the surface, there is a lot of processes that are happening at the surface. At the surface, that's where we find plants, and plants will absorb water. And remember, we started off with the sun, right? So the sun continues to provide energy for this process again. So as plants are photosynthesizing, they then also require water, and they take up water from the ground through a process called transpiration. And once they've taken up that water, they release that water through their leaves, openings in their leaves called the stomata, and that is a process called transpiration. So transpiration is basically when the plants absorb water from the ground and then release it through their leaves. And this also adds to that evaporated water, and sometimes you will find a word where you have a combination of evaporation and transpiration, which is evapotranspiration. And this also adds back the water to the atmosphere and begins this whole cycle